product called SmartCane. SmartCane is built for all the blind and visually impaired people living around the world. At present, there's 3 million people just in America who are either blind or visually impaired. This makes it very hard for them to move around without the help of another person. SmartCane will make it easier for all the blind people to move around without the help of someone else.
So in order to make SmartCane, we plan on implementing several things, one of which is an ultrasonic sensor. This ultrasonic sensor will measure the distance between the blind person and an object or obstacle on the road. Alongside this ultrasonic sensor, we plan on implementing a servo. This servo will rotate the ultrasonic sensor 180 degrees, such that we can see objects all along the blind person's path. Another thing we plan on implementing is a buzzer. So what this buzzer will do is that if the distance between the blind person and an object is near, then the frequency of the sound the buzzer emits will be higher. Whereas if the distance between the blind person and an object is farther away, then the frequency of the sound will decrease. Another thing we plan on implementing is an accelerometer. So what this accelerometer will do is that upon a change in reading of the accelerometer, the SmartCane will light up an LED. The reason we do this is that at nighttime, when the blind person is using the SmartCane, other people will be able to see him because of the lit up SmartCane.
Finally, we're going to have a GPS chip inside the SmartCane. This GPS chip is going to send the location of the blind person to another caretaker via Wi-Fi. This could be very helpful in cases of emergency and generally for the caretaker to keep track of the blind person and his or her movements.
Here we can see that as you move closer to this ultrasonic sensor, the frequency of the beep increases. This is used to aid the blind person.
In this clip, we can see the servo. The servo is, more specifically, a micro servo, which rotates 180 degrees. It has a ground, power, and signal pin, each of which we've connected to their corresponding places in the breadboard.
We later plan on attaching our hardware onto this stick to make it our very own SmartCane.
Lastly, we have some footage to explain the program we have thus far. First, we have some code to illustrate the first rotation of the servo from 0 to 180 degrees of increment 1 degree. We then exit this loop and proceed towards an if statement in order to create the buzzer sounds. The delay determines the frequency of the beeps. We then go to the next for loop to create the rotation of the servo in the opposite direction. Once again, we have code for the buzzer. This code is not final as we are still experiencing some gimmicks. We also have yet to implement the accelerometer in the following code. However, included here is the basis of the code we are presently planning.
Thank you for watching and stay tuned for SmartCane.